Welcome to this Excel tutorial for exercises 7 and 8, Absolute Cell Reference and Goal Seek. Let's start with exercise 7. As you can see, we want to invest $35,000 in a fund, and the fund gives you an average yearly return of 7%. That 7% is placed in cell C6. We're probably going to use that later. Next, we're given a table with a bunch of blue cells. We're probably going to fill out these cells later, but let's understand the table first. Along the columns, we have year 1 to 10. Along the first row, we have the balance as of January 1st, which is $35,000. That's what we start with our investment. Next, we have the return, and then the balance in the end of that year on December 31st. So if I wanted to know what my return was for year 1, I would place that here, and the balance at the end of year 1 would be placed here. Then I would go on and take the balance from the end of year 1 and place that in year 2. That's where I would start on January 1st of year 2. Then I would get the return for year 2, and then I would add those two and get the balance at the end of year 2 in December 31st. And then I would continue this process all the way till year 10. And at the end of year 10, I will know what my balance is after 10 years. Okay, let's look at the questions now. Question 1, in fact, asks us, what is your balance after 10 years? We need this number over here. If you understood my explanation of the table correctly, this number will give us the answer to question A. So let's fill out this table. First off, to get the return for year 1 and then the balance at the end of year 1, we need to perform some calculations. If we perform these calculations correctly, we might not need to repeat them for the rest of the years. So let's get the return for year 1. So we know that we're starting out with a $35,000 investment. So if I want the return after 1 year, I multiply how much I invest by the return for the year. In this cell, I'll type equals 35,000 times 7%. Before I hit enter, I want to use an absolute reference for the yearly return, because that is not going to change. Later, I'm going to pull this formula to the right all the way till I get to year 10. I don't want this cell reference to change. C6 should stay C6 for all of these years. So I'm going to lock this cell and make it an absolute reference. The quick and easy way to do that is directly after I click on the cell, click the F4 key on my keyboard. As you can see, that puts dollar signs in front of the C and the 6. This makes this cell an absolute cell reference. It won't change when I autofill it later. I leave the cell reference C9 a relative cell reference because this cell will change each year, and I want it to move when I perform an autofill later. Now let's click enter and see what the return will be after 1 year of investing $35,000 at 7%. $2,450. I don't need the cents, so I can format that very quickly by decreasing the decimal places. Let's get the balance at the end of the year. To do this, I'm going to sum the balance at the beginning and the return. So equals sum, and I can highlight these two cells, close parentheses, hit enter. I could have also done this simply by doing equals, clicking on this cell, and then using the plus sign on the keyboard and clicking on the return cell. I get the same results. That's great. After 1 year, my $35,000 is $37,450. In year 2, I will carry this amount over. So here, I'm going to reference this cell. Equals, click on this cell, hit enter. You see the 37,450 appears up here, as well as it being connected to this cell. So if this changes as well. That's a good way to set this table up. Next, the return after year 2 will be the balance at the beginning of year 2 times the yearly return again. That's the same calculation we did here. So I don't need to repeat this a second time, especially because I made this an absolute cell reference. I can drag this formula to the right now. And I see that my return in year 2 will be slightly more than my return for year 1 because I have a bigger balance at the beginning of year 2. Again, I can sum both these cells to see what the balance will be after year 2. But I've already done this calculation, so I can autofill this by dragging this to the right. Next, for year 3, the end balance of year 2 will be the beginning balance. But I've already done this, so all these calculations are going to repeat for each of the years that follow. Because I took some time and thought at the beginning in year 1, I don't have to repeat these formulas again all the way to year 10. I can drag each of these rows to the right, or simultaneously highlight them all and drag them together. This is a neat function of autofill. Everything fills out, and we see that after 10 years, on December 31st of the 10th year, my ending balance will be $68,850. And that's what question A asks us. So here we can simply refer to the cell that contains the year 10 ending balance. And that's the answer to question A. Question B, what yearly return do you need to have a balance of $80,000 after 10 years? Well, let's think about what this question is asking us. This question is asking us, what would this number, yearly return, have to change to in order for this number, balance after 10 years, to be $80,000? In order to perform this calculation, we need to solve a complicated equation. In order to do this, first we have set up this table. Since all of these results depend on each other and are connected to each other through cell references and formulas, we should be able to use Excel's help to calculate what yearly return will have to become in order for year 10 ending balance to become $80,000. Okay, let's put the result in this cell. Now to do this, we need to use a functionality in Excel called Goal Seek. So go over to the Data ribbon, and then you'll see What If Analysis. What we're asking here is, what would return have to be in order for balance to be 80,000? So to click on this, we see there's a Goal Seek option. Goal Seek will perform this calculation and solve this equation for us, provided we have set up all our cells with formulas instead of typing numbers in. Click on Goal Seek and we get a little dialog box. First thing we need to tell it is which cell we want to change. So this is the cell we want to change. What do we want to change the cell to? Well, we want to change it to 80,000. Don't type in commas here. Just type 80,000. And finally, by changing cell, here we need to give Excel which cell we want to change in order for this cell to become 80,000. And for this, we're asked what would yearly return need to be. So we're going to click on this cell. So Excel is going to change this in order to make this 80,000. So clicking on yearly return and remembering that we took some time in setting up this table with proper formulas, click OK, and Excel quickly performs the calculation and tells us that yearly return will have to be 8.62% in order for $35,000 to grow to $80,000 exactly after 10 years. That's the answer to our question B. So let's simply type this in. Let's convert it to a percent by using some of our formatting skills. Show more decimal places. Perfect. We've answered this question. Now let's return this to 7% and we get back to our old numbers. Question C. What yearly return do you need to have a balance of $50,000 after 5 years? That's asking me, what does yearly return need to change to in order for end of 5th year balance to be 50,000? So once again, GoalSeek will do this for us. We go over to the data ribbon, what if analysis, GoalSeek. This time we want to set year 5 ending balance to 50,000 by changing yearly return. Click OK. All the numbers change. We end up with exactly what we were looking for, $50,000 at the end of year 5, and we see that yearly return would have to be 7.39% for us to achieve this goal. That's why it's called GoalSeek. Click OK. Let's type 7.39%, convert it to a percentage to make it look right, show more decimal places, and we've answered questions B and C using GoalSeek. Great. Let's move on to exercise 8 now. In exercise 8, we're looking at a fixed principal loan from our bank. The loan has 10 annual payments with a 5% interest rate. Question A asks us to fill out the blue cells and make an amortization schedule. Before we look at this table, let's take a look at some of the properties of the loan. The loan is for $100,000, the interest rate is 5%, and the term is 10 years. So, looking at the table, we see we have the terms set up for 10 payments. The principal reflects the loan amount. And what we're left to do is to fill out the rest of these cells. So let's get started with that. Let's start with term 1. In term 1, the principal payment is going to be the loan amount divided by the term. So equals divided by, and we have a principal payment of $10,000. It's going to take us 10 years or 10 terms to repay the principal of $100,000. So it's no surprise that one term principal payment is $10,000. Next, let's calculate the interest payment for term 1. Equals the principal times the interest rate. Now, I could hit enter and I would get the interest payment. But eventually, I want to be able to drag this formula down. So once again, I'm going to utilize absolute cell references. Eventually, I'm going to drag this formula down. I don't want to have to repeat all this work too many times. So to minimize my work, I think a little about what's coming. And I realize that this formula is going to get pulled down. When it gets pulled down, the principal may change because we're paying down the principal, $10,000. So next year, the principal is going to be $90,000. But the interest rate, which is cell C29, that's not going to change. So I want to leave cell reference F29, which is this cell, relative, and make cell reference C29, which is the interest rate, absolute. This way, this will not change when I drag this formula down, but this will change as the principal gets reduced with each payment. So let's do that. Back in the formula bar, I click F4 and it puts dollar signs in front of the C and the 29, and so this cell reference is now an absolute cell reference. It will not change when I autofill later. Let's hit enter, and we see that I have a principal payment of $10,000 and an interest payment of $5,000 in term 1. The total loan payment is going to be simply the sum of the principal and the interest. Perfect. Loan payment 1, $15,000. Now, we go to year 2. Year 2, the principal has changed because we've paid down the principal, $10,000. So let's reflect this. Equals the original principal, or the principal from the term before, minus the principal payment. Of course, we knew that this was going to be $90,000. The principal payment, however, stays the same. So we're simply going to refer to the cell above. The interest payment is now based on a much lower principal. The interest rate is identical. If you remember, when we performed the formula up here for term 1, we made this an absolute cell reference. We left this relative. So if we pull this formula down instead of retyping it, we'll see what happens. It's actually different than in term 1. Why? Because now 5% is being calculated off of $90,000 principal instead of $100,000. So its interest payment is slightly less. We can also click on the cell and click the F2 key on our keyboard, and Excel will highlight the cells involved in this formula. And we can see that this moved down while this cell reference stayed stationary. This is because we made this an absolute cell reference, as you can see in the formula bar. Hit enter, and then the loan payment is going to be the sum of these two. We already performed this calculation. We can autofill, grabbing the bottom right hand corner black plus sign and dragging down. Okay, great. I think we've done enough. I don't think we need to do any more formulas. We can simply drag all these down now. Now, we can do these individually. And they will update as I fill in the rest. Or I can undo what I did and show you how I could have done this simultaneously at once by highlighting the whole row and then grabbing the bottom right hand corner and dragging them down all together. And since all these were connected with formulas, these numbers should reflect the correct principal, principal payment, interest, and loan payment for all 10 terms. Great. Now let's move on to question B. What is the total interest expense during the 10 years? Well, we did all this work already. Here are the interest payments for each of the 10 years. So let's simply sum them up and see what that is. Equals sum, open parentheses, highlight all 10 interest payments, close parentheses, hit enter. We see that our total interest payment during the 10 years is $27,500. Now let's pull that into this blue cell by referencing that. Equals, and simply clicking on cell H39 brings that number here, and this cell is now connected to this cell. Question C. Another bank offers you 4.5% interest. What would the interest expense be if you choose this bank? All we need to do is to change the interest rate here, because everything we did was connected with formulas and references. Everything will update. 4.5. And you see that we have a much lower interest payment after 10 years. Let's write that in this cell. Let's also format it to be a comma-separated variable. Because we're dealing with bigger numbers, it's always nice to use commas. Now, before we move on to question D, notice what happened in question B. This also changed. Wasn't it 27,500 before I changed the interest rate? Why did it change? Well, because if I click in the cell, I referenced cell H39. So this cell is always looking to this cell. And if this changes, this also changes. So if we don't want that to happen, we should simply hard code the number in by typing it in. So let's go back and change this to 5% interest and get back to our original answer. And as you can see, this updated, and we learned an important lesson here. So if we don't want this to change as we change the interest rate, let's simply type in this amount. Okay, great. Now let's go to question D. Calculate how large the interest rate needs to be for the total interest expense to be $26,000. So let's break this down. We want to see what the interest rate needs to change to in order for the total interest expense to equal $26,000. All right, that sounds like another goal-seek problem. Because we've set this entire table up properly with formulas, we can use Excel to calculate what this interest rate needs to change to in order for this to become $26,000. All right, here's goal-seek again. Data ribbon, what if analysis, goal-seek. Okay, let's think. Set cell. That's going to be the cell we want to change. Total interest. What do we want to change it to? 26,000 exactly. By changing cells, that's the interest rate. The interest rate is the variable here. We click OK, and Excel finds that the interest rate would have to be 4.373% in order for the total interest to be $26,000. I format this total interest and interest rate to a percentage with 2 decimal places, and I've answered the question of what the interest rate needs to be for the total interest expense to equal $26,000 exactly. Okay, great. So now we see the power of goal-seek and absolute references. Okay, great. We successfully completed the exercises together. Your Excel skills are getting better and better. Now keep up the good work by doing more exercises and practicing. Till next time, goodbye.